All right, now we're going to transition to the next portion of this lesson. So we're going to be done with domain and range, and now we're going to start up with extrema and real roots. As a reminder, a root is something that crosses the x-axis. We can also call it a zero or an x-intercept. An extrema is where the graph has either a maximum or a minimum. So if you ever hear those terms, that's what it's referring to. But this has an extra adjective. The word is real. And why I want to draw attention to this is because we had real zeros. I'm going to use the word zeros. You can say roots, but I usually say zeros. You can have real, and you can also have imaginary zeros or roots. I don't know if you remember this. Imaginary ones you cannot see, but you can tell by the equation how many they are. It's the highest power. This problem only wants to know the real ones. So as you look at the graph, all you're doing is counting how many times does this actually cross the x-axis. What do you think? How many times does it cross, Eric? That's right. This has 4 real zeros. 1, 2, 3, 4. I did that in red. So it has 4 real zeros. So real ones are the ones you can see. That's it. You know, remember that because we're about to go to a different problem where I use a different adjective. 4 are the ones that are real that you can see. Extrema means the little maximums or minimums, the hills and the valleys, if you will. So on the graph, this would be like a valley. This would be a little hill. Any hill or valley you count for extrema. They're the maximums and minimums. How many do we have on this problem? That's correct.
3.
1, 2, 3. There's 3. If you had to be more specific, this is a minimum, and not only is it a minimum, since it's the lowest part in the graph, they would call this an absolute minimum. That's an absolute minimum, would be more descriptive. This minimum is different because it's not the lowest. You could call it a local minimum, or sometimes we call it a relative minimum. They can use either adjective. So if you ever see that, that's all it means. It means it's just a minimum, but not the lowest part in the whole graph. This right here would be a maximum. What type? Is it local or relative max, or is it an absolute max?
Absolute.
So a lot of people think absolute because it's the highest, that's a maximum. But is the graph actually higher on these portions? Yeah, so because of that, we would just call that a local or relative if you wanted to use that word. You can just pick one, max. Okay, so there's the descriptions on that. So I told you, be very careful because the test makers in the past, I've seen them be tricky, where sometimes they say how many real roots, sometimes they'll say how many total. I didn't put that up there. Total would be real plus imaginary would equal the total roots. So you got to be paying attention to what they ask for. So let me find the next problem that has to deal with this. Here we go. Number 19. A polynomial function of degree 4 is graphed as shown. Based on this graph, what statement is true concerning its roots and extrema? And here's where I say many students it's just a simple mistake, but it's just because you're moving fast. How many real roots do you see in this problem?
2.
There's 2 real roots. 2 real roots. And so many students go through here and they say it has to have 2 roots. And so they mark out these options and they select one of these. But you see how this has the word total? You know what total means?
Yeah, even the imaginary.
Even the imaginary. So how do you know how many imaginaries there are? They have to tell you. They'll either give you an equation or tell you what's called the degree. The degree means the highest power. On this problem, you see up at the top how it says the degree is 4?
Yeah.
The degree is telling you how many total. This will have 4 total roots. So this one's a trick question. So these 2 are wrong because it has more than 2. It has 4. Again, the degree is telling you the highest power is a 4, and the highest power tells you how many total roots there are. That would tell you there are 4 total roots. Okay, next question. What about extrema? How many hills and valleys do you see?
3.
Very good. It would be 3. Not 5. It'd be, there we go, 3. By the way, Extrema is 1 less. The maximum is 1 less. There's if you have 4 total roots, you must have 3 Extrema, or at most 3, like that. Okay, it's 1 less. And I think I have 1 more of these before I give you your DOL. Yeah, here it is. Next problem. Mike is given an equation in this form, where all of these are real numbers. What are the greatest number of zeros and relative extrema in this function? So if you're just paying attention when I said, you'll have your answer right off the bat.
It's 4.
It's 4. 4 what?
4.
4 for both of these, zeros and extrema?
4, 3.
4 and 3. Good, Eric. Good job, by the way, both of y'all. Why is it 4 zeros?
Because of the power. It tells you how many zeros you have.
Whoops, all of that tells you. The highest power tells you everything. This has 4 total zeros,
And 1 less.
and extrema is 1 less. That's so ugly. Let me write this again. 4 total zeros, and 1 less extrema, which means 3 extrema. And I'll show you why this makes sense real quickly. I'll just draw a few graphs. Here's why it makes sense. If your graph, this is an equation, that's a line, which comes from an equation that's like y equals mx plus b, but x to the first power. How many times does this actually cross the x-axis? Once. How many turns are there?
1.
Turns, or extrema. Extrema is kind of like a turn, a maximum or minimums. How many turns does this have, or how many hills, or how many valleys? 0. It's always 1 less. This had 1 0, and no turns, no extrema, no minimum, no maximums. Okay, that was a line. Well, let's now check out a different graph. What if we had a parabola? How many zeros do you see in this parabola? 2. Remember, this comes from the equation y equals x squared. How many zeros do you see?
2.
2. How many extrema does it have?
1.
Only 1. You see how it's 1 less? So you could keep doing this forever. I'll do just one more example. I'll do an x cubed graph. X cubed looks like an S curve, kind of like that. How many zeros do you see? 3. How many turns or extrema does it have? 2. You see how it's always 1 less? It'll just keep playing this out. This one would have been 4. I said I was going to do one more. I lied. I'm going to do, so 4 powers would look something like this. It would come through and go 1, 2, 3, 4. It has 4, but to get 4 zeros, that means you have to turn or change directions 3 times. So extrema, another name for extrema, is just a turn. The graph turns your direction 3 times. All right, and I think that's all of them. Yep. All right, so DOL time. Open up, go over to the zeros and extrema, and do this problem right.